review session and putting it into CTLS as a YouTube link. All links to the videos are located in your CTLS under midterm review links and documents. So this is all there for you. All right, so here we go. The first thing we did was just some old factoring. Quadratics. And that means we have x squared or 2x's. So this is factoring things like x squared plus 10x minus 24. I think that works. All right, so this is x squared. It is a trinomial, so we will use the x method. Factors of negative 24 that add to a positive 10. Now the trick here, because it is a negative 24, we will have opposite signs.
6 and 4.
So,
Wait, no.
okay. 6 and 4 seems to work here, but it is not the pair. Somebody else said one?
It's 12 and negative 2.
It's 12 and negative 2. Yeah, 24 is always a tricky factor because you got to watch this sign. So yes, I'm glad. 6 and 4 probably would have been on my radar too, but 10 and negative 2 are actually the pair that work. So x plus 12, x minus 2. In the directions, it would only ask us to factor, so we can stop here. Also, it's not set equal to 0, so that's another just clue that we are not setting this equal to 0 and going further. So also, we talked about factoring a difference of squares. X squared minus 4. You could think about this as factors of negative 4 that added to 0 if you wanted to. These are evil twins, so we'll use a positive 2 and a negative 2. How many questions will be on the midterm? There are 30 questions on the midterm. 30.
So if you could like chunk it up based on like each separate problem, it could be like per problem.
One of each type.
I'm trying to see if that's accurate.
I think it's accurate. Okay. So that was old stuff, but we went over the old stuff in order to prepare for the new stuff. So this is factoring a quartic. So x to the 4th trinomial. One, two, 3 terms. So a little bit of vocab review for you. There is a naming problem on the midterm. You will have to have those names somewhere. All right, so a quartic trinomial looks something like this. X to the 4th minus 17x squared plus 72. So this problem sort of feels familiar-ish. These are the problems that I call pretend.
Isn't that when you take the 4 and turn it into a 2?
That's right. I pretend it's x squared minus 17x plus 72. Oops. And so then I can find factors of 72 that add to negative 17. Negative 9 and negative 8. So x minus 9, x minus 8. But we have to remember that we didn't just have 2 x's, we really had 4. So you have to put those extra x's back in. But then you have to check for more factoring. And the checklist is it a minus? And is it a perfect?
Negative 9 is a perfect square.
That's right.
You could take an extra step and go x minus 3 and then x plus 3, right?
That's right.
And then you bring the 2x minus 8 down. Yeah.
Exactly. So Sayer just told me all of the steps that I just took. So if you thought I was jumping to the end, I was just listening to Sayer. He was rocking and rolling. So he said because 9 is a perfect square and it's a minus, you could factor that into the x plus 3, x minus 3. I couldn't do that on the 8 because 8 is not a perfect square. 8 is 1 times 8 or 2 times 4. And only a perfect square would work here. So this is our final answer. Does anyone need to see that again? It should be sort of fresh on your mind. It wasn't that long ago that we talked about this. So if you need me to do another example, just shout it out. The next thing we did was a sum or difference of perfect cubes. That's a terrible cube, but I tried my best. Can connect some of this here. It doesn't look like a cube. You know what it looks like? A shoddy cardboard box. But that's okay. All right. So our perfect cubes are 1, 8, 27, 64, 125, and I'm pretty sure I wouldn't give you something higher than that. So we'll just make that list stop right there. There is a formula for this. It is A, B, A squared, AB, B squared. The signs are the same, opposite, always plus. So the problems will look like this. Let's say 8x cubed plus 27. So we'll break each term into triplets. So 8 is 2 times 2 times 2, and x times x times x. So something that Sayer did, he said, let's just do 2x, 2x, 2x. And that really works for what we're about to do, so that's cool. And then 27 is 3 times 3 times 3. So that gives me the A and the B. So now the next part is A squared. So you can either think about this as 2 squared and x squared, which would be 4x squared. You could also think about it as I'm going to take these remaining pieces and multiply them together. 2 times 2 is 4, x times x is x squared. The middle piece is A times B. So I'm going to take 2x times 3, which will be 6x in the middle. And the last part will be B squared, which is 3 times 3, which is 9. The signs will be the same, opposite, always plus. Would you like to see another problem like that? Yeah? Okay. Let's do 64x cubed minus 1. So 64 is 4 times 4 times 4. So I've got 4x, 4x, 4x. And 1 is 1 times 1 times 1. So here's A and B. So 4x and 1. So in this A squared part, I've got to take 4 squared and x squared. This is usually where people make a small mistake, because it's going to end up being 16. Oops. Okay. 16x squared. 4x times 1 is 4x. Yeah, sorry, it's just messy. And then last is b squared, or 1 squared, which is just a 1. the signs will be the same as the original, so minus. This one will be opposite. This one's always plus. These? These are the only numbers that we can use in problems like this. So it'll always be those specific numbers. You're welcome. All right, the last thing that we saw was the factor and remainder theorem. And this is where you had several steps that you had to take. So step one was to use synthetic division. You're going to get a remainder of 0. For sure, for sure. So this is when you were mentally looking for that, because in the directions it'll say one factor has been given. The fact that they use the word given tells you the remainder is 0. After you use a synthetic division, you're going to factor the new trinomial, the new factor what's left. Factor what's left using the X method. So your answer should have 3 pieces. Make sure to include the given. A lot of students lost credit here on this Delta Math quiz because they either didn't factor what was left, or they only gave me 2 pieces, not 3. So just be aware of that. All right, so here is an example problem. Who knows what number problem this is? All right, so in step 1, I'm going to take x cubed plus 2x squared minus 9x minus 18 and divide it by x plus 3. So this is a review on synthetic division. We're going to set this equal to 0 and subtract. I'm going to use a -3 in the box. I drop down only the numbers in front, so 1, 2, -9, -18. I will get a 0 at the end, I already know, because they said given. -3 times 1 is -3. 2 minus 3 is -1. -3 times -1 is +3. -9 plus 3 is -6. -3 times -6 is +18. Happy dance. Now, we're going to need to factor. 1x squared minus 1x minus 6. Two and 3. And the 3 is negative. X plus 2, x minus 3. But we're also going to include the given, x plus 3. Sorry, include given. Sorry. Would y'all like to see that again? No. There is on the midterm. So the directions for this specific problem were to factor. But if they had asked us to solve using a given, we would have done the same process, but to solve, if they asked us to solve, they would have wanted us to set all of those factors equal to 0 and give them answers. So, oh, no, Miss Bartlett. I would have subtracted 2, added 3, and subtracted 3. So I would have gotten -2, 3, and -3 as answers if they wanted me to solve. These are called zeros. Do you guys have any questions about what you have seen here? Okay. I'm going to stop the recording.